Hello everyone and welcome. Welcome to this afternoon's panel discussion. I'd like to introduce you to our panel chair and keynote speaker, Karel Osten. After many years in engineering companies, Karel has recently become an independent consultant specializing in gold pressure ox. He was kindly our keynote speaker this morning, and we thank him for his support of this event. He's well known to many of you, so without further ado, I'm going to hand the panel over to our chair, Karel Osten.
Thank you very much, Alison. And in turn, I'd like to introduce the members of the panel that Alison and Ellen have brought together to discuss the topic of cyanide alleviation and alternative lixiviants for you. Just running through in initial order, I think you will have seen everyone except for Paul earlier today. We've got Danielle, who's from Cyro normally, there she is, but she's obviously had a, I don't know if you'd call it a sabbatical, but she's moved up to Cal this year, and she's been doing something quite special up there in terms of education, which is wonderful. And she spoke to us earlier today about analysis of gold lixiviant solutions. Next on my list is Professor Dave Dreisinger, who I'm sure everybody knows from UBC, who's joining us after his afternoon, or should we say evening beer over there in Vancouver. So I hope it's all okay for you there, Dave. I won't bother with his bio because he's got more awards than is decent. But anyway, he's been around for a while and knows what he's talking about. Then we have Christina, who I don't think I've met before, but she also presented today on the interesting topic of thiosulphate leaching. So she'll have something to say as we get down to that portion of it. Next is Malcolm Patterson, who's the CEO of Green Gold Minerals, and the driving force between, or in terms of the recent technology that he talked about today and has talked about previously. Malcolm has the dubious honor of being my boss at one stage, and wasn't a bad chap. So thanks for coming along, Malcolm. We have Paul, who knows everything about gold chemistry and cyanide chemistry. So he's your go-to man if you have any questions about that. And we're very glad to have him here today, providing his significant expertise of over 20 years, I think it is, at Cyro. And the latecomer to today's panel, last but certainly not least, Frank Trask, who's actually a mining engineer and a geologist by training. So he's in pretty dubious company today. But presented an interesting paper on leaching with glycine and additives, which certainly I found quite interesting. So thanks for coming, Frank. Just for everybody's, just to make sure everybody's aware, we have the question chat window open that you should be able to see. Please type in your questions, and if I can manage the technology, I will relay these questions to the panel as best I can. So you should be able to see the topics that we've nominated for today's discussion, and they're in hopefully a logical order, where we talk about the environment that we're working in at the moment, particularly the regulations, look how the industry has been over recent years, look at how we measure what we do, and then go into the nuts and bolts of the various technologies for cyanide recovery or alternative lixiviants. So to start off, I'd like to see what the panel's views are about any changes to the regulatory environment in terms of governance, whether it's in specific countries, whether it's from financiers, institutions like the World Bank, or possibly from the ICMI in terms of the cyanide code. Paul, would you like to kick us off with your thoughts on that?
Thanks, Carl. I don't have a lot to add at the moment in that regard, because I haven't had a lot of association with the governments and NGOs in that regard. I guess the movement or the community side of it is more what we hear about, and the social license to operate. And there's, you know, obviously still a movement around the world to try and get away from cyanide if we can. But still there's that acceptance of, you know, cyanide is so robust that, you know, it's going to be around for some time yet. Yeah. So, you know, I think that's where we're at as an industry. Yeah, that's sort of, I think, where we're at as an industry. We've got to keep working on the alternatives, because there are some jurisdictions and areas where cyanide isn't able to be used, and justifiably. They're quite environmentally sensitive areas, and we need to come up with alternatives in those places. But where that sensitivity is not there, then we still have the freedom at the moment to operate with cyanide. So, and obviously we should be doing the best we can with cyanide and trying to reduce the risks and impacts that we have with that. And yeah, as you've seen today, there's quite a number of activities still going on to improve what we're doing with cyanide.
David, could you comment about the view from North America? I mean, I don't know whether you could weave in any potential political changes that might affect people's thinking south of where you are.
I won't comment on the political situation. That's a taboo subject, I would say.
Oh, no, understood. Only its potential impact on regulation.
Yeah, I imagine that there'll be swings and roundabouts on the regulation side. You know, it went one way in the previous administration. It might go another way in the next administration. I'm not sure what the movement will be there. But I think the perception in North America is that you know, cyanide is a tried and true chemical for use very widely in the ores that we have around North America. Probably the only notable exception has been the use of thiosulphate at Goldstrike for Barrick, where they're dealing with the carbonaceous products coming out of an autoclave treatment. So in that case, the drive has been to look at an alternative for process reasons, not for environmental reasons. But generally, with respect to environmental practice and cyanide usage, I think the regulatory environment's pretty stable, and the operators have been pretty responsible. We don't normally hear of many upsets or difficulties with the use of cyanide in North America. So I don't think it's kind of a burning issue in terms of social license or so on in North America at this point.
And thanks, David. And what's the view in Indonesia, Malcolm? You've got to turn your microphone on.
Yes, just saying up to myself, I'm actually in Perth at the moment, not in Jakarta. So I'm in a much safer place. It's all good. Yeah, so the view, I guess, green gold is not just based in Indonesia. Of course, it's very much got an international spread now. So we're doing projects in quite a few continents and countries. So it's we try and look at it from an international point of view. But the whole basis, of course, of our technology is that we are still using cyanide because we just think that it's still one of the most proven lixiviant of all. And for us to actually look at a new lixiviant, you have to then look at all the implications of that downstream as well. And people say, yeah, it's great, new lixiviants, they're not cyanide. But then you have to understand, what is the impact of those new lixiviants? At least cyanide we understand, and as we've said often, the approach that we take is just to reduce that impact. People feel comfortable with cyanide in a process point of view, but in terms of the environment, then that's what we're trying to address. And the economics as well, of course, by recycling it really has its advantages. So we
But are your clients typically responding to commercial pressures, or I think, as Paul mentioned before, the influence of NGOs if they aren't?
So I think cyanide's still going to apply.
Sorry, I missed that. Malcolm?
Right, yeah, it just says my internet's unstable. That's no good, is it? Okay. 5G.
Sorry, Malcolm,
Yes.
I mean, are you seeing your clients responding to commercial pressures or societal pressures, NGOs and so on?
It's a bit of both. I think people like to be seen to be green, is always one aspect. But commercially and economically, it's the big push, really.
Frank, do you have any thoughts on this side of it?
Well, our clients seem to live in a fear of changes of regulation, and they're trying to be proactive to react to what they perceive could be something that could happen in the future. In other words, they're attempting to make their business sustainable, and we agree with almost everybody. Cyanide's a very, very good reagent, very hard to replace. And we found a few niche markets where we might be able to replace it, or at least if not replace it, certainly cut the usage of it to quite a remarkable degree in a few instances. But it's being driven by a perception of what the environmental movement might do.
Mm. And these, I take it, would be potential future operators rather than existing operations.
Oh no, existing operators are very sensitive. Not so much in WA, but in other parts of Australia, people have to renew their license conditions on a fairly short time span each time, and there's always a push to see what have you done to cut your use of cyanide.
Okay, but that can also tie into the recycle and better management as well.
Oh yeah, I mean, it is what it is.
Mm.
Yeah, that's exactly right.
Christina, any thoughts?
I guess a lot of the clients that we're dealing with at the moment have those stranded assets where they can't actually use cyanide. So that's the ones that we're really trying to give a viable option to. And then there are some, especially in Australia, where the governments are moving away from it. So obviously in the national parks in Victoria, you can't use the cyanide, so we need another option for that. And we've had some inquiries through the Northern Territory government that have sent people to us because they don't want to give any more cyanide licenses in that area. So it's really just about changing people's attitudes, and it will eventually move to a slightly more environmentally friendly, but obviously cyanide is very good and it's effective, so it'll take a long time.
And it's the gorilla in the room, isn't it? Danielle, any thoughts?
In some respects, I was our fourth year mining engineering students presented yesterday on their research projects, and a couple of students did some analysis on regulations from a Western Australian context. And perhaps it may have been more of a mining engineering focus, but I was really interested to see the results from the survey, in as much as a lot of the people that had responded to the survey, they covered the full gamut of roles within the sector. And I think just in light of this particular conversation, a lot of the different roles didn't necessarily see regulation as having an impact on their particular day-to-day activities. And it was just one of those things where I thought about, particularly when we come into this context in talking about perhaps instituting regulations and restrictions when it comes to using different chemicals, there does need to be that broader conversation that is had throughout organisations about these decisions that get made. So it's not just about having a conversation with the hierarchy. There needs to be a whole, it just seemed to me as though there's that opportunity to bring everybody into the conversation about why these decisions are being made. I suppose that's my contribution to this particular topic.
Well, in terms of, I mean, are you talking about the community engagement or in the business?
I think it's a little bit of both. really. The students were interviewing people who are process technicians, who are mining engineers, who are mine planners, so people who are actually working in the organisations. And there just seemed to be a bit of a disconnect with some of the roles in whether understanding regulations actually applies to them. And yes, it was just one of these moments where I thought, oh, maybe particularly when we talk about downstream processing or different gold chemistries, there's that conversation piece that needs to be had with our metallurgists, with our process technicians, to help them understand why these decisions are being made.
I would suggest not just with cyanide, but all sorts of other issues where we all have a responsibility. I can only make, in a personal sense, an observation from the work I'm doing or done in Turkey the last few years, is that I think 20 years ago, and Malcolm, you would have been part of it, trying to get a gold project up in Turkey was, or maybe longer than 20 years, it was almost impossible, but now it seems to be accepted as long as it's properly managed. Microphone.
Yeah, I quite agree. And to me, we have to take a step back and really look at the public perception. And where does that perception come from? Are we, is it going to be easier to change that perception, or to introduce something that's new that we then have to, convince people afresh? Because I think, is cyanide really a bad boy? Is it really that bad if it's well managed?
I think the point is we have a responsibility and a duty of care to manage it properly, and otherwise we don't have the social license to operate. And if we don't do it, then the NGOs have got every right to get upset. We've got to do the right thing.
Sure,
I think there's no doubt about it. And the technologies that we're talking about, whether it's alternatives or better management, are all part of that conversation. I see Alan's chimed in, and I think this leads on to, as a segue, as our friends in the broadcast industry call it, to the next topic, which is sort of industry practice and track record. Alan's question relates to the focus on tailings dam stability, because there have obviously been catastrophic failures. The Barre Marie failure was a tailings failure in terms of, certainly in terms of management. I'd argue that it wasn't as catastrophic as the more recent failures in Brazil, for example, and I think in British Columbia you had a pretty bad one a few years ago. But I think Alan's question goes to, even if people aren't so much focused on cyanide as perhaps they might have been previously, has the concern about the stability of tailings had an impact? And I think, Christina, one of your points was that with the technology, it goes, this is one of the questions I had for you, was that it goes hand in hand with dry stacking. I don't know whether that was mandatory or just required in terms of the economics of the recycle of reagent.
It's needed for the recycle of the reagent. So with the,
it's a double-edged thing.
Yeah, we run the system in excess for leaching kinetics. So obviously you want to recover as much reagent as possible, otherwise the economics don't quite make sense, because you don't actually use all of it during your reaction. So you want to be able to pull it back. And yeah, dry stack tailings is a sort of a new thing that is eventually going to come out and be used, which would be exciting. It does remove the need for a tailings dam, but it is getting people's head around sort of a new concept that everyone's used to a normal tailings dam. But with the dry stack tailings, there's no risk of sort of those failures that we've been seeing.
No, but I mean, depending on the climate you're in, dry doesn't necessarily remain dry forever.
No.
So I mean, we have to make sure that whatever's deposited is not going to impact the environment once it's irrigated. I mean, can you say that about the technology?
What we have as part of our technology is obviously the non-toxic, but if there is something already in the ore that is hazardous, that we're never going to remove that with our technology. It will always be there, but that will be the same as cyanide. So
it's not a complete get out of jail free card, but it does certainly eliminate the short-term concern about cyanide.
Yes, definitely. We can't fix problem ores, and if there are contaminants in the ore, there's really nothing out there that I'm aware of that we can use to remove things.
So it's always going to be an issue, just a matter of degree. Anybody else like to chime in?
Yeah, I was going to say I'm a strong proponent of alternative to cyanide when you need them, but cyanide is just a wonderful chemical. I mean, we use it in sparing amounts. When we're done with it, we can chemically decompose it to innocuous byproducts. We don't have to have a dangerous situation in tailings or in impoundments if we manage our cyanide properly. The gold industry has come together on the cyanide code, and we've got worldwide buy-in on this plan of how to manage cyanide on our sites, how to report properly, how to make sure we do things safely. I think it's a real model for other industries. I know
that's true.
The copper industry that's trying to talk about what to do about arsenic. A lot of arsenic moves in copper concentrates around the world from mines to smelters and other plants. They're looking at the cyanide code as kind of a model for how you might look at a potentially damaging component of your process stream and how to think about managing it and making sure that it's regularized all over the world. So I think the gold industry and the use of cyanide is actually a world leader in that regard. And you don't hear many stories of big upsets involving cyanide anymore, to the gold industry's credit. I think some of those more damaging incidents are somewhat back in history and maybe not to be repeated anytime soon, I would hope. But I'm certain.
I'd very much agree with that. And I think, we realize that we're on notice. We have to do the right thing, and all of those things that you've spoken about lead to that. I've got a question from Andrew Hawkey, which is, I think, related to filtration, but and it says, have cyanide limits been determined for dry stacked gold tails? Well, I think dry is never completely dry, so I would presume that the limits would be akin to what they are for non-dry stacked material. But Paul, do you have any thoughts on that?
Yeah, no, I suspect at the moment the regulations would be that the moisture within the dry stack tails would have to have the regulatory requirements of what cyanide levels consistent with what they are for wet tails. I haven't seen any moves to move away from that.
I think we're ahead of the regulators as far as that goes.
Yeah.
And I think, getting back to David's point, certainly my anecdotal experience is that since we had a bad run 20 years ago with some bad mishaps, the impression I get is that the industry has been looking after itself, and there hasn't been the sort of headline grabbing terrible incidents that we've seen. I don't know if everybody would agree.
Yeah, part of the thing about tailings dams, Karel, is that sometimes it's a geotechnical problem. It's not cyanide. The disasters are caused partly by just the release of those tailings. And as you say, dry stack is not solving the problem completely if it's in a wet environment. Well, same with heap leaching, you still get failures.
I mean, if you built a dry stack tailings dam in a positive rainfall area in British Columbia or in Brazil, it wouldn't remain dry for very long. So you're going to have to manage that. It may not potentially be as much of an issue as a conventional dam, but I think it's certainly still an issue. All right, unless anybody's got anything else to offer on that, and no more questions. Now here, Danielle, this is I think made for you, but everybody else, maybe David can chime in, and Christina, and Paul from an academic perspective. We can't manage what we can't measure. So I'd just like to raise the topic of what improvements we've seen in terms of cyanide monitoring, and particularly speciation, so that we can understand whether we've got thiocyanates or thiosulphates, because these are obviously quite tricky and often difficult to do in a mine site. what improvements have been made over the last few years. I mean, perhaps Danielle, you could lead us off.
Thanks, Karel. Certainly, I can speak to the work that I used to do with Paul in terms of being able to measure a number of different species, particularly using high-performance liquid chromatography. So that's obviously that opportunity that we've been able to explore using that equipment in our laboratories and other research colleagues' laboratories to be able to separate those sorts of species. I think from the review that I did, and I, in some respects, focused predominantly on where our colleagues had done research, particularly looking at gold leaching systems, as opposed to more broadly looking at individual components, so wastewater treatment and so on and so forth. Though I do note that in some of the more recent research, there has been colleagues who have gone and looked at what else is being done elsewhere when it comes to wastewater and those sorts of things. I think, again, it was still coming back to some of those more complex systems, or I suppose perhaps equipment that's a bit more cumbersome than a titration. So I do feel as though there's that opportunity for us to look at how we can I suppose, enable our process operators to quickly and easily determine concentrations. That being said, I am aware there is a group, I think it's in Germany, that have developed, it's almost like an indicator capsule using some form of complex that changes colour, that gives you an indication of your wad cyanide concentration. So I know there is some work being done in that particular space. And it's a really exciting area where you're getting that entrepreneurial spirit in people trying to identify niche markets where they can enable site measurement that's quick and easy. So that's been my sort of reflection, has been at the moment, I think there still seems to be that tendency for us to gravitate toward high performance liquid chromatography, spectrophotometry, those sorts of systems that don't necessarily work out in the field. So I do think that there's opportunity for us to further refine.
But isn't there a difference between what's in the field in terms of what the operator does and what's in the lab? And even there, I can understand that some mine sites will be a lot better equipped and be able to manage having ICP and HPLC. Relative to what the guys got on the bench up on the leach train. But I mean, have there been developments in HPLC technology making it smaller and cheaper and easier for mine sites to deploy in the same analytical labs that are doing the rest of their accounting analyses?
So certainly I know that both at Goldstrike and the demonstration plant at Menzies, there were smaller units that were being used. I think and so there is that opportunity to do things in the field. I think part of what I've reflected upon is that there's still that requirement to improve, because you end up with complex solutions. There's still that requirement to upskill perhaps process technicians to interpret chromatograms and understand where and what it is that you're actually looking at. I think that's been part of my personal experience, is that you're not just looking at one compound, we're looking at complex, or one component in a solution. You're looking at solutions that contain a variety of anions or cations, and how do you discern which one is which if your equipment isn't working properly? And so that's part of, I suppose, what I've reflected upon in recent times.
Thanks. And Malcolm, up in Indonesia, I mean, what are they using for speciation?
Oh, it's very, very simple titration, because you're really limited by what you can do. And the operator has enough trouble just trying to control pH and cyanide levels. If you're trying to do much more speciation than that, it's really out of their control. But back in the lab, it's totally different. And we do struggle a bit in Indonesia with some of these more exotic analysis. And we have to send samples back to Australia to get them fully analyzed. But in terms of on-site, it's not easy at all. You know, it's very basic stuff, because that's all the operator can do.
And I think I would suggest that we need to draw a distinction between the operator and what's in the lab. But ultimately, even if it's impractical in the lab, it's going to be, in terms of managing, you know, thiocyanate and that sort of thing, it's going to limit our ability to do it as well as we'd want to, I'd suggest. Any comments?
Yeah, I was going to add, Karel, I think you've got to consider also what the measurement's for. So if the measurement's for control in the circuit, then you have usually a lot more freedom, or a lot more, you don't need the accuracy necessarily to control the process. But where you're doing it for regulatory reporting, in terms of like a wad cyanide analysis at the end of the process, then it needs to be, you know, more rigorous and follow standard methods and so forth. So, you know, I think there's some room for us to be innovative around, particularly, you know, control measurements within a process. And, you know, you see that in terms of some of the wad cyanide measurements that are used to control the cyanide destruction process, but then they'll have samples taken off-site and analysed for their regulatory reporting requirements. You know, so I think there's, you know, and we're looking at that in terms of for thiosulphate systems as well. You know, we would like to have all the information in terms of what we can get out of the HPLC, but obviously we realise that having a HPLC on site and someone with the capabilities and skills to run a HPLC is, you know, going to be highly unlikely unless you're a big operation like Barrick.
Yeah.
And you know, you're putting millions of dollars into a process that you need to understand because you're doing it for the first time. But for those who are wanting a process that's a little bit more robust to run, then, you know, you want to be able to just control your reagent addition, what is your top-ups, and then have the ability to access capabilities off-site that can give you the more detailed analysis that you might need to troubleshoot. So I think that's where, as an industry, we've sort of got a, or I guess organisations like CSIRO are trying to support the industry in, you know, adapting the more complex analyses into something that's a bit simpler on site for the fit for purpose.
Okay, and I think, well, we've seen in terms of automated analyses, you know, Chemtronics and other companies like that, and, you know, that's certainly established in the marketplace. Any other comments that anybody would like to make about improvements to the ability to perform analyses, or the rigor with which companies are performing their balances, their overall water management and balances on site? No. All right. We've got a question, and it sort of goes back a couple of steps, but let's carry on with it. And I hope I'm pronouncing your name properly. It's Fatima Niku. Is the permissible level of cyanide different in different areas? If yes, can we say glycine is an alternative when cyanide level is a problem? I suspect the answer to the last question is certainly yes. My view, and others may like to comment, is that every regional jurisdiction will have its own requirements depending on the way the laws are set up. But I think the cyanide code is reasonably well accepted all the way around the world. So I think there's a bit of both there. Any other comments? No, moving on. Okay, I think let's get into the nuts and bolts of the process, which is the cyanide recovery and recycle developments. And here I've put resin, AVR, SART, thickening, and dry stacking. So this is right up your alley, Malcolm, because obviously you've seen for a number of years the opportunity in terms of using resin for cyanide recovery, although it was, I think, around in the 1980s, it just didn't get anywhere for whatever reason. So I know you've talked about it a bit in your presentation, but how do you see resin being, you know, comparing to other technologies for cyanide recovery, be there AVR, SART, or whatever?
Well, we certainly believe that it has a lot of potential, but it's going to be a long road. I think with any of these technologies, it just takes so many years to get things accepted into a very conservative mining industry. Now, it doesn't matter if it's glycine or resin, whatever. It's a long haul, the bloody long haul. When I say long haul, I mean like 10 years, 20 years. We've been at this now for 30 years.
Well, that's what I was thinking, because my first recollections of it were from the 1980s.
Yes, yeah, and it goes back even further. It goes back even further, but yeah, and there are reasons for it. There are reasons for this that it has been delayed, but I believe now we are on the right track. But it's a parallel track. We are trying to change the perception of cyanide and make that more acceptable and find some real solutions so that tailings dams don't become a problem from a cyanide point of view. There's still a problem, obviously, from vast amounts of contained slurry that could be released, but that's not a cyanide problem. And I guess having alternative lixiviants is a way to satisfy another group of people that are concerned with cyanide. But for me, it's really turning around that perception about cyanide. My thing is, as David has said, it's not all bad. And there's a perception out there that cyanide is bad, and that's really driving, I believe, the alternatives. Cyanide disappears. It's not cyanide that's a problem in a tailings dam. It disappears. Sulfides are even more important. We're doing a project at the moment in Queensland, which is Mount Morgan, 100 years old, never used cyanide, an environmental disaster because sulfide, metals, nothing to do with cyanide, a disaster. They've never used cyanide. So to me, it's just, again, getting back to that perception.
Well, I think, would anybody disagree? How about that? How about the proponents of non-cyanide lixiviants? Frank?
Well, we say outright and always have that cyanide's a very good lixiviant. It's a good thing that goes to work every day for a lot of people. However, there are systems, particularly where there's things like copper present, where you can get some very, very high uses of cyanide, making a great deal of wad cyanide, that sort of thing. And our glycat system does control that. And we have found that we're able to cut the use of cyanide from between 20 to 80%. And furthermore, the cyanide we do add, if you're going to define cyanide by a Volhart titration, which seems to be a standard way of doing it, it's not present anymore. It's obviously present as some sort of glycine cyanide complex. We have a pretty good idea what they are, but we've got a lot of very clever computational chemists working on it and things like that. But at the end of the day, you're putting out a tailings with no detectable cyanide and very, very low wad cyanide, and you've saved an awful lot of cyanide, and the cost is a modest amount of glycine, which can be recycled through the tailings, if you wish, that type of thing. We've also found that we can use mixtures of cyanide and glycine on ordinary free milling ores that people have been using cyanide on very happily for a long time. And we can get the same results or even better recoveries with half or 2/3 of the cyanide with a modest amount of glycine added to it. And that's, I know at least one potential customer, he's capable of maybe getting 2 or 3% more gold. It's got him very interested, at least. So yeah, it isn't just trying to go against cyanide. It's trying to make a system that uses cyanide better.
Mm-hmm. One of the things struck me is that, sorry, go ahead.
We're quite happy to have copper in the ores, cyanide soluble copper, because we recover the copper. It's a revenue for us, and we recover the cyanide that's associated with that copper. So for us, it's not a problem. The higher the copper, the better. because it's we get both gains.
I was going to ask a question about that, Malcolm. I mean, because if I understand it correctly, the copper is in the chloride system. Are there alternatives to that for sites that are sensitive about chloride?
Yes, yeah, we have several different elements we can use, and cyanide is actually one of them. We can actually take the copper out with cyanide in that elution stream, and we precipitate the copper using NaSH. We get a very pure form of copper sulfide, almost 100%, very pure, and then the cyanide is recovered as part of that process.
Because I mean, one of the applications certainly that strikes me is that in low pH systems, which might include POX or roasting or whatever they are, but certainly POX, particularly if there is some recycle, there's often thiocyanate present at low pH, and there's the potential for its recovery from that solution stream, not necessarily the main slurry stream.
Yes, that's right. Yeah.
So you have thiocyanate and the copper complexes that go with it, and we're sort of drifting off a bit, but that's fine. Because I was going to ask David from your paper that's presented today, that involves the use of solvent extraction, but introducing solvent extraction to a should we say a simple cyanide plant or gold circuit is potentially quite a stretch, with issues to do with fire, contamination, whatever. Is there any opportunity to use resin as opposed to, I mean, solid ion exchange as opposed to liquid ion exchange?
System we chose for our recovery was a solvent system because it had the chemistry that allowed us to strip it with lime rather than with caustic. So we wanted to be able to affect a more easy recovery and recycle of thiocyanate. We've been looking at the university at thiocyanate as an alternative to cyanide. It's sort of a half step away from cyanide because it still has the cyanide molecule embedded in the thiocyanate, but it is a different chemical, and it does have a nice efficiency for use of gold leaching at low pH. So if you're doing a POX, and instead of having to take the POX discharge up to pH above 10 to use cyanide, with thiocyanate, you might be able to use a much lower pH and not have all that base consumption to try to raise the pH up to such a high level. And then coupled with that is the ability to recover it with the solvent. I think the comments you made about the the safety and so on about solvent extraction are all quite appropriate. But of course, the copper industry recovers 20% of the world's copper by solvent extraction at mine sites all over the world. So it can be done safely with the available technology, and the solvents that we're using are not not novel or flammable to a greater extent than what would be used already in the gold industry. So in the copper industry, excuse me. So I don't think it's a particular concern that we'd have to overcome there. We were just looking at thiocyanate generally, and then trying to make sure we could recover it and control it through the circuit to have a good efficiency in its use.
Yeah, go ahead, Frank.
I'd just like to point out an experience. We have a small operating mine using our system in Zimbabwe, and they're leaching what are supposedly jig tails that go about 3 to 5% copper and between 2 and 5 grams of gold. And they're leaching them in fairly simple vats, but they're using our glycat system, and they're recovering their gold in 2 to 3 days, and then continue on leaching the cyanide. Without any trouble, and the copper is all recovered. When they get the clear liquid, they precipitate the copper as copper sulfide, which they bag and ship off to a smelter, and the gold is then put on carbon and run through a normal process to a doré bar. And It's early days yet, but they're actually using it, and it works well, and they don't have any trouble in the midst of the upper regions of the Limpopo River. They're doing great.
Well, that's good to hear. I think the more good news stories we can have in Zimbabwe, the better, would be my think about it. Beautiful country. Paul, in terms of SART, I know that Sarah was looking at that in terms of improvements to the technology a few years ago. Haven't heard too much about it recently, but can you comment on developments on that, if any?
So in situ recovery is an option that's been looked at and explored for a number of years, and obviously Sarah kicked off with an invisible mining sort of symposium a few years ago, and there's still been momentum from that. And as part of this conference now, there's the in situ recovery symposium. So there's still a lot of work going on that space. The lixiviant part of it's only a very small challenge. A lot of it, particularly for gold processing, is around how do you get the access to the gold in the ore. A lot of our ores, we typically have got a mill and crushed down to 75 micron P80s to liberate the gold. So if you're not bringing the ore to the surface and crushing and grinding to that level, then how do you get that release of the gold in situ? So that's where the in situ lies as a real challenge. It's more around that access, liberation, and I think a lot of the work in that space has progressed in more recent years, in the last couple of years, more to looking at more of a block cave type in-place leach rather than specifically an in situ leach for gold deposits. Slightly different for copper and some of the other elements that you can chase, because they do tend to have some or better hydrology, but not so much for gold ores. They're very few and far between the paleo channel type deposits where we can potentially do in situ without having to do too much disturbance to the ore body in situ.
Okay, well, yeah, I mean, which sort of brings us on to thiourea. What lixiviant were they using or for that work, Paul?
So there's been a number of lixiviants looked at. I think there was some recent work done as part of the groups that have been looking at the in situ side of things and been looking at even the glycine, thiosulphate, thiourea, and there may have been a few others have been evaluated. Iodine iodide's always been sort of on the cards as a bit of a benchmark for the system. But there's still a lot of ongoing work, and as I said, the lixiviant system, you can look at it in terms of what are the reactions that go on. The gold stability tends to be the biggest challenge in all of these systems. Once the oxidant gets depleted, often the gold will become unstable and become easily preg-robbed, and so you end up with not being able to flush the gold easily from the system until you've oxidized the whole system. So they're some of the challenges that are faced depending on the deposit mineralogy.
Yeah, and certainly, I'd echo that. Was my experience dealing a long time ago with thiourea for in situ leaching. You had to keep the chemistry right, otherwise you lost all your reagent. And Frank, I was interested to see your results with the thiourea today.
Yeah, well, it's again, it's a system that we're pretty sure we chemically understand what's going on, and it's the stabilization of the ferric ion as ferric glycinate, which is still an effective oxidant for gold, but it's not strong enough to oxidize the thiourea, or that appears to be what goes on. So that's something that hasn't gotten past 20 or 30 or 40 bottle rolls, something like that. And we're expending some effort and work on it, and hopefully we'll get somewhere. But
well, maybe you need an autoclave to make some ferric for you.
Well, an autoclave, maybe one of those Albion systems can do it too.
So they say. And well, now we're firmly into alternative lixiviants. So So
Sorry, Carol,
various
can I
proponents can duke it out. Sorry, go ahead.
I just wanted to know, Frank, what are you using? Are you using 2 titrations to measure the glycine and the thiourea?
I'd have to ask the chap from Curtin, El Said,
I'll test him then, not a worry.
He certainly does the glycine titration, because we do it for him. We have a little automatic titrator now, and that does a very good job of getting unassociated glycine. But I'd add very quickly, we always refer any experiment of any importance back to a baseline series of determinations done by HPLC, which are expensive, but they are authoritative. So it's quite good. Mm-hmm.
I see we have a question from Angela Duchesne. Hopefully that's correct, Angela. When and where does the panel anticipate the next commercial installation of an alternative lixiviant at a larger mine? Any views on that? Particularly,
well, we're going into our 3rd pilot plant to install our glycat at Endeavour's Lake Cowell project in New South Wales. And there seems to be a firm path forward to install it on their concentrate leaching. And amongst the chemical simplicity, the ability to possibly get any question of problems with cyanide or WAD in their tailings, combined with the simplicity, the beauty of the glycat thing into an operating mill is probably the biggest single expense. You might have to put in a tank to hold the glycine, although you can mix it with the cyanide if you want to. And there's nothing else to do, and the quantities of glycine are low enough that the people seem to be quite willing, when compared to the savings on cyanide, to say goodbye to it in the tailings pond. What they get back later is, well, they'll enjoy it if it comes back, sort of thing.
And Frank, this is replacing an existing contactor for leaching the
yeah, well, they're floating a pyrite-rich concentrate, and they're leaching it and getting a recovery. You can find out what it is if you want to read their annual reports. But they're using between 8 and 10 kilos of cyanide per ton. We've got them down to 1.8, 1.9 kilos of cyanide per ton and 2 kilos of glycine, which cost about as much as a kilo of cyanide. So if you're doing 1,000 tons a day, it doesn't, even I can come up with a figure without having to count my fingers there.
And so, yeah, thanks. Christina, where's your next major installation?
So we're working with a client at the moment out of Southern Cross, and so they're hopefully actually starting their plant construction early next year. So we'll be looking at sort of 2021, we'll have an operating plant up and running, and they're looking at between 20 and 40 ton per hour of processing.
Okay, and I mean, it's still, I mean, apart from Barrick as Goldstrike, as was mentioned previously, it's still small steps, and I think, I forget how you put it in your paper, Malcolm, but this reluctance or the resistance to change, how did you qualify it? Oh, you had a phrase for it in one of your slides at the end.
Yes. Oh, that was the quote from the book. Yes, yeah. That's right. Yeah.
Oh, anyway, so I mean, you know, Barrick is a big example. It's a very specific one, and not everybody can do that. But anyway, it's encouraging that you're getting one in next year. Any thoughts from your part of the world, David?
Yeah, I think I want to mention something that I noticed in some of my travels, Carol, that, you know, some of these new technologies, they take a long time to get developed, and then when they're implemented, critical issue is supporting them in the application. So visiting Goldstrike, you know, sometime after the plant was started up, you know, with the constant rotation of people through the site and changing metallurgists on the thiosulphate plant, the preservation of a body of knowledge on how to operate these plants or how to optimize them, quickly gets dissipated. And so it's a real operational and managerial struggle to try to keep ahead of that sort of thing at the site. People that do cyanidation are pretty common throughout the world in the gold industry, but people that do thiosulphate leaching, have to be specially trained to be able to do that successfully. And of course, if they move onward or upward, that operating knowledge can be lost very easily. I also reflect back to some of my experience at the Telfer site in West Australia with the SART plant there, where the SART plant was started up first at a small scale, and then Telfer went through a much larger expansion, and a larger SART plant was put in. But I remember visiting the second larger plant and having the same issue that, the new graduate got the SART plant operation, and they were struggling, right, with how to operate the thing, and it wasn't the main body of the plant, it was the reagent recovery part of the plant, not the gold making part of the plant. And it's hard in some of these remote locations, especially with the rapidly changing workforce, to really support these new initiatives properly. So I see that as a major impediment, not so much the mining industry's reluctance to adopt new technology, which of course is certainly there as well, but the need to support it and make it successful in the long term is quite a challenge as well, I think.
So that goes to having a critical mass of experience and maintaining that. And well, I think we could reflect on this more generally for anything that's a bit out of the ordinary, because you see it in some of the refractory technologies that are a bit more specialized. You have to maintain the skills and you have to invest in people, otherwise it's not going to happen. Maybe this is a bit of an indictment on the industry. I'll leave this to people to discuss that. You can't just assume that if you don't train somebody, you can hire somebody who is trained. You're going to have to make sure you put the effort in, and even if you train one person after another person after another person, it's part of the job. Any thoughts?
I think for me, it was, and that was part of what I reflected upon at the end of my presentation, was if you are in that, if we end up in that circumstance where, and whether it's a niche application or there's that shift in industry, and you're looking at an alternative reagent, you do need to consider your workforce and who is out there that you have the potential to be able to train in the new chemistry, because even from my experience, from a Gold Strike perspective, they took operators from a cyanide plant and trained them up in the thiosulphate plant. And even though you've exchanged the carbon for the resin, and you're still using leach tanks, and there's titrations and all of those sorts of things, there's recirculating streams, and it's different chemistry, and metallurgists as well. So I think it's incredibly important for us, where we are at this particular point in time, to remember the importance of retaining that knowledge and thinking and considering about how we ensure that if we are going to implement a new way of recovering gold, how do we ensure its greatest chance of success?
And Christina, can you comment about your client? I mean, have they recognized that a risk, and how are they managing it?
Yeah, a lot of it will be up to us ensuring that we provide the knowledge to not only the clients, but provide them the manuals and some understanding of what they're actually got. So if somebody leaves, then, there is still available material for the next person to learn. And part of what we'll always be doing at Clean Mining is providing that ongoing support that, if you do have that constant turnover and you do have new metallurgists that need retraining, we will always be a part of assisting to make sure that we keep on top of this, and that your system doesn't fall down just because you've lost people and you've lost the knowledge on site.
Yeah, I'd agree with that. Just whilst we're here, a technical question: what's the lowest pH you've successfully used your system?
I have to check with Paul for that one.
Oh, okay.
He's got all the test work.
Oh, that's a good handle.
Yeah, we typically operating around pH 6 to 7, but it depends on the ore a little bit. We can go a bit higher, but 6 to 7 is the ideal
I'd like to go lower. I mean, well, no, it's not true. But
below 4, you start destroying thiosulphate.
Yeah, that's right. So in other words, that's the barrier at 4, and then
yeah.
I mean, is there a question of kinetics at the slightly higher pH?
It depends on the systems you're running, and I guess what you need to achieve. So some oxidants have better solubility around the more neutral pHs than up at elevated pH. Whereas if you're looking to use a copper ammonia oxidant system, obviously you want ammonia there, so you need to be up, above pH 9, 10 sort of region to get your stability.
But I mean, so if we are looking at an acidic system, we at least have to use, say, limestone to get us up to that pH, if not a bit of lime.
Correct. Yeah. If you had a pressure ox or bio-leach process up front, then yeah, there's still some neutralization that needs to be done.
I mean, it's the bulk of the acid, but if you had a buffering system with manganese, magnesium, whatever up there, then at least, I mean, apart from that, it'll build up in solution. You don't have to deal with that. Yeah,
correct. So the hypersaline waters that we have around Kalgoorlie, where it costs an arm and a leg to get above pH 9, then yeah, for those waters, it's quite a good system to be operating more neutral.
Right. Any comments from anyone else on? Well, I mean, I think we're almost out of time. Final comments on alternative lixiviants. It looks like we're going to get a small thiosulphate plant in next year, which is encouraging. Anybody aware of anything else? When's your plant going to be built in? I mean, it's not quite the same subject, but when's your plant going to be built in? Is it Mexico, Malcolm?
Well, we're just commissioning a 6 million ton a year resin plant in Indonesia at the moment. So we're sort of getting up there now in terms of size of plant.
Is that Matabe?
That's Matabe, yeah. And we've done plants at 1 million, 2 million, and now we're up to 6 million ton a year. So it's getting, we're getting some good experience, and it's a steep learning curve. It really is for these new technologies. We're not denying that. So we are getting that experience, and you only really get that with these large commercial plants.
Mm-hmm.
That's when you really do, the proof of the pudding is there. And that's what gets the acceptance in the industry. And that book you were referring to was called Crossing the Chasm, and it's a huge chasm, mm-hmm. getting that acceptance. And it's only when you've got these industrial commercial plants up and running and proven that people start really talking about acceptance. And that's where we're at the moment.
As you were discussing in the nickel industry with some of the skeptical voices about, should we say, conventional HPAL technology, saying, well, by the time it's accepted, we found something else and want to move on. But
yes,
that's just the joys of developing technology. So I think we're pretty much out of time. Any final thoughts on alternative lixiviants? Anything you'd like to share with us before we have to leave? Frank?
Well, we like to think that the plants that we're going to install glycat in are already built and already running.
Okay.
So simplicity, simplicity, simplicity. That's it.
Yep, that's a good way to go, Frank. Simplicity. Yes. It's the only way.
Right, Alison. I don't know if you're in the wings, but I think we're pretty much on time. And I would certainly like to thank David, Malcolm, Frank, Danielle, and Christina, and finally, but lastly but not least, Paul, for helping me out today. Thank you.
And I in turn would like to thank you all, and also to thank Karel for hosting today's panel discussions. These discussions are important for the industry, and we do share them. We make them available to everyone, and we imagine this discussion will continue into social media later on when we share it. So thank you all very much for your time, and also for your presentations during the conference. Thanks, and bye bye.
Thank you.